Hi, this is Javier Encinas, and today we're going to discuss a very important subject, the calculation of deflections in continuous concrete beams. When we design a beam, we focus our attention in the calculations of the shears and moments, and sometimes we overlook the calculations of the deflection. This is very important as well because that affects the serviceability of the structure. I have prepared an example in ASDIP concrete to illustrate the point. It's a continuous beam, two span. The first span is 24 feet long and the second span is 20 feet long. It's subject to some distributed loads and some concentrated loads as well. So it's a typical continuous beam. In ASDIP concrete you can specify different types of sections, rectangular, T-beams, spandrel beams, inverted T, or L-beams. In this case we're going to use a T-beam as a typical beam in a concrete building. In this case is 24 inches deep total. The slab is 6 inches thick and the beam width is 12 inches and the flanges are 12 inches as well. The materials, we're going to use a F'(C) 4 KSI and FY60 KSI for the reinforcing steel. In the load tab, we're going to use a set of load cases and let us to combine them. Very important, the percentage of live load that is continuously applied is 30%. This is very important for the calculation of deflections. And we're going to use uniform loads, 2 KSF dead and 1 KSF live for both spans. And the concentrated loads, 2 kips dead and 1 kip live in both spans, as shown here graphically. So let's get started. If we go to the at a glance tab, you can see a summary of the results. Here we can see that everything is passing, but today we're going to focus only on the deflections. In the deflections area, we can see that the beam is passing in all conditions except the third condition, and we're going to see what that is in a moment. We go to the condensed tab. Here you can see a more detailed set of calculations grouped by topic. And if we scroll down, we go to the deflections area here. ASDIP concrete calculates the deflections for these load combinations and load cases, including the sustained life and the long-term deflections as well. In addition, ASDIP concrete calculates the properties of the section, the crack properties, the effective moment of inertia for dead, live, sustained life, and calculates also the lambda factor for the long term. Here you can see the maximum deflections. This is based on the ACI code and it refers to different types of structures. For example, roof not attached to non-structural elements, floors not attached to non-structural elements. The type C is attached to elements likely to be damaged, and D is attached to elements not likely to be damaged. In our case, we can see that the calculated deflection complies with the code, except for the type C. So in this case, this beam can use everywhere, except if the structure or the beam is attached to elements likely to be damaged. If we go to the detail tab, we can see in more detail the calculations here, also grouped by topic, but showing step-by-step calculations and showing the formulas exposed, and also references to the ACI code. If we scroll down to the area of the deflection, which starts just there, we can see what ASDIP concrete calculates. It calculates the properties of the sections for inertia gross, also the moment cracking, and the effective inertia for dead plus live, for life sustained. All this is calculated for the mid span of the span number 1, but also since this is a continuous beam, it's also calculated for the support. Same properties. Here we calculate inertia gross, the inertia cracking, the moment cracking, and then the inertia effective for the same load cases. Here the software calculates a weighted average of the properties, effective moment of inertia for dead and dead plus live, life sustained, dead alone, using 85% for the center and 18% for the support. So this is a weighted average. With these average properties, the program calculates the deflections for dead, for live, dead plus live, for live alone, and for dead plus live sustained. And with this, we calculate the long-term deflection here. So with these numbers, the program compares the results with the limitations, with the allowable deflections per ACI. For example, for the condition A, the allowable deflection is L over 180. In this case, it's 1.6 inches, which is more than is 0 in this case because we don't have any live load. And type B, the allowable deflection is L over 360, which in this case is 0.8 inches, but the calculated live deflection is 0.18, so it's passing. For the third case, type C, this is more stringent, it's L over 480. In this case, it's 0.6 inches, which is less than the calculated deflection at 0.71, so this is not passing. That's why this beam can be used everywhere except for this condition, for roofs or floors supporting or attached to non-structural elements likely to be damaged. Okay, so as you can see, ASDIP Concrete calculates very accurately the properties and the deflections for a continuous concrete beam. The program also reports the contents calculations. Here we can see the deflection area, so with the results that we already discussed. Here the maximum deflections and the comparison to the ACI code. And of course the program also reports the images and all the rest of the calculations. The program also generates the detailed report. Here, bending design, here is the shear, and here starts the deflection. Here are the calculation of the properties at the midspan. Here are the average of the calculations for the support and the midspan, and the calculations of the deflections here. And then the comparison to the allowable limits. As you can see, ASDIP Concrete calculates the deflection very quickly and accurately, which otherwise would be very time consuming if you do it by hand. So this is a very handy tool for the design of concrete beams, and in particular for the calculations of deflections. Well, thank you very much for your attention, and see you in the next video.